Hi guys, today we're on Unit 9, Lesson 5, and we're going to be solving trig equations. So the first thing we want to remember is we're going to solve a trig equation just like we would a regular equation, and in which case we're going to isolate the variable. So what is the variable in a trig equation? Well, the variable is going to be our angle, which in most cases is going to be theta. Sometimes it will be given to you as an x value. Okay, so just remember that. And this is not an ordered pair. This is just different ways we can represent our variable. So our steps, once again, we're going to isolate theta. Okay. Then we want to solve over the given interval. Which in most cases is going to be 0 less than or equal to theta, which is less than 2 pi. If you want to think in terms of degrees, it's going to be from 0 to 360. And just notice that that 360 is not included in the interval. Okay, so you're really not going to include if you get 2 pi or 360 as your answer. And for the most part, we're going to set it equal to 0. And then we're going to factor if needed. We may have to use identities. And the identities, basically we studied before break. Those are all the different double angle, Pythagorean, and whatnot. And sometimes we may use other algebraic methods. So this would include, if necessary, the quadratic formula or solving for a square root, so etc. We're just going to, you treat it just like a regular equations. Now our solutions. Our solutions are a little tricky. Okay, we have to be kind of think about things when we're dealing with this. So we're going to use inverse trig to solve for the positive function value. Okay, be careful of that. And then adjust for the quadrant. So this is going to be basically, we're using a reference angle, which we've done in the past. So once we have our reference angle, then we have to think about what quadrants will our solutions be in. And to narrow down our solutions, we go back to our old standard, our quadrants where our function values are positive. So if our solutions, okay, remember, it's all students take calculus. Everything's positive in quadrant 1. The sine is positive in quadrant 2. The tangent is positive in quadrant 3. And the cosine is positive in quadrant 4. I'm just going to kind of go down here a little bit with these to give me more room to work in my picture. All right, so for solving our equation, sorry, this is not going to work. All right, we'll just leave it like that. If we're solving our equation, okay, remember, we're going to always solve for the positive reference angle. And then we adjust for our quadrant. So to get a second quadrant value of our solution, right? If theta is in the first quadrant, the theta is the reference angle. If theta is a second quadrant value, we do 180 minus r. If we want to get our solution in the third quadrant, now this is a little tricky here. Think about this. You're going to do 180 plus your reference angle. So it's a little bit different than when we were setting up function values. And then if we want to get the value of our solution in the fourth quadrant, theta is going to equal 360 minus r. And we can do this in terms of degrees, and sometimes we're going to be asked to do it in terms of radian. So basically, if you get your answer in terms of degrees, you should be able to convert it to a radian measure if needed. So let's talk about how we can just apply all of this. Okay, so we want to solve each equation on the interval 0 to 2 pi. And technically speaking, our answer should be in radian, but I'm just going to adjust this for today's lesson. And this is less than, that should not be there. We're going to leave our answers in terms of degrees today. And we want to give the exact value of theta when possible. So in our first example, sine of theta equals 0.523. So basically, I want to get the angle by itself. I'm going to use my inverse trig. If I want to find the value of that angle, I want to find the angle that gives me a sine. Remember, that's what that inverse trig means. The angle that gives me a sine of 0.523. So I go to my calculator. I make sure I'm in degree mode. And I just go second sine 0.523. And that angle, my reference angle, is 31.5. We're just going to round to one spot for today. So I have 31.5 degrees. Now I consider my function value. My function value is positive. What do I mean by that? The sign out front. Since there's nothing there, I know this is a positive function value. So I think to myself, where is the sign positive? Well, the sign is positive in quadrants 1 and quadrants 2. So I already have my quadrant 1 function value of the angle. In order to get the other solution, I'm going to calculate that value, 180 minus 31.5. So my solution set would be 31.5 degrees and 148.5 degrees. Now, do you necessarily have to do the little XY axis and the quadrants? No. I understand that some of you don't need that visual aid, but it's there to be helpful to remind you of what to do. Now let's look at the next problem. Sine of theta equals -1/2. So remember, in order to do this, we're going to start by getting our reference angle. And that's going to be the angle whose sine is 1/2. Now, some of you may recognize right away and may not need to go to your calculator. The angle that gives you a sine of positive 1/2 is 30 degrees, right? And that's coming from our triangles. And if you'd like to do that, you can. You can use your triangle, you can use your mental ability, and in calculus, you're going to be expected sometimes to not have the use of a calculator, so you shouldn't forget this approach. The angle whose sine is 1/2 is 30, but now we have to adjust for our function value. We're looking for the quadrants where the sign is negative. So our solution is not going to be in the first or the second quadrant. It's going to be in the third and the fourth quadrant. So we have to adjust and find the value of this angle, 180 plus 30. So one solution is 210. 360 minus 30. Our other solution is 330 degrees. And we can put it in set notation to be nice and official. Now let's kind of jump down to a little bit more difficult of a problem. So now I have 2 cosine theta minus 1 equals 0. Remember, we're trying to get this by itself, just the cosine. Cosine theta by itself. So just like you would do with a regular equation, you're going to bring the 1 over and divide by 2. So we really, if we're solving for the positive function value, always do the positive. I want the angle whose cosine is 1/2. We could work off our triangles if you want. You can go to your calculator if you want. I'm not going to be too critical of what method you use. The angle that gives me a cosine of 1/2 is 60. And remember, this is your reference angle. Now I need to think about what is the function value? We're solving for a positive function value because there's no sign in front of my 1/2. Where is the cosine positive? In quadrant 1. So that's one solution. And in quadrant 4. So my other solution is 300 degrees. Okay, and you'll notice lots of times you're going to get two answers when our angle falls in between and in one of the quadrants. If it's a quadrant value, then you may only get one answer. So we have to be aware of that and be careful. 4 cosine squared theta minus cosine theta minus 1 equals 0. Okay. Now we're dealing with something a little bit more tricky. If you think about this, this is really like solving that equation. We want to get the x squared. How do we typically solve an equation that's what we call quadratic, right? This is x squared, so it's a quadratic. Well, everything's already on one side. Okay. So our second step would be to see if we can factor it. This happens to be a tricky trinomial, so we're going to have to do a little work here to factor this. Last year, when you were solving trig equations, your teacher may have had you rewrite them with the x. Okay. I'm not necessarily a fan of that, but if you need to do it that way, that's absolutely fine. I just keep my trig function and factor it that way. So moving on with our factoring, tricky trinomial. So I have 2 cos, 2 cos, 2 numbers that multiply to -2 and combine to give me -1. So I have -2 and +1. Put in a factor of 2 dividing out. Cosine theta -1, 2 cosine theta +1. Now continuing on, we're going to set each factor equal to 0. For the left factor, we get cosine theta equals 1. So now we want to think about where does the cosine of theta equal 1? You can, always you can use your calculator if you want, but be very careful. So when I'm dealing with a situation like this, and I know my function value is a positive or a negative value, I'm sorry, 0 or 1, I'm thinking I actually go to my curve itself. Okay. I find this to be a little bit easier of a method. Where's the cosine? What angle gives me a cosine of 1? Well, that's going to happen at 0 and 2 pi. But remember, we're not including that in our interval. So my answer is going to be 0. So be really careful when you recognize that your solution is going to be a quadrant angle. I would recommend using either the unit circle or the actual graph. Moving back over here to solve for the other factor, cosine theta equals -1/2. So we were going to solve for just the positive function value. I want the angle whose cosine is 1/2. And that's going to be a 60-degree angle. Okay. And remember, that's our reference angle. But we want to find the value of 60 degrees to get our solutions. We want the value of 60 degrees where the cosine is negative. So the cosine is negative in quadrants 2 and 3. So notice that 60 degree, That's not going to be one of our solutions. We're not going to use it as a solution. We're just going to use it to help us get our real solutions. 180 minus 60, 180 plus 60. So the actual solution set for this trig equation is 0 degrees. 180 minus 60 is 120. 180 plus 60 is 240. So, we are building in difficulty. We started out simple, got a little more complicated. Now we're going to deal with some reciprocal trig functions. Okay, so how do we deal with these? Well, this example is nice and easy because it's already factored for us. So to get our solutions, all we really have to do is set each of these factors equal to 0. Cotan theta plus 1 equals 0. Cosecant theta minus 1/2 equals 0. Cotan theta equals -1. So instead of trying to, because you're not going to find a second cotan button on your calculator. I don't think you have it. Let's see. Nope. We'd have to do a lot of work there. So let's use our reciprocal identities. That's where the tangent of theta is 1 over -1, which is just -1 as well. And hopefully you guys recognize. And if you don't, use your calculator here. Positive function value, right? We just want to solve for where the tangent is 1. Some of you already know it's going to be 45 degrees, but if you forgot, no big deal. Second tan 1. And we see that our reference angle is 45 degrees. Now we go and adjust it for our sine. Since the sine is negative, we know we're going to be dealing with quadrant 2 and quadrant 4. 180 minus 45, 360 minus 45. So to the two solutions from this factor, 180 minus 45 is 135 and 315. And now let's approach our other factor. Cosecant theta, I'm going to bring the 1/2 to the other side. Now, instead of finding where the cosecant is 1/2, adjust it. Remember, we can just flip the sign or flip the function value. The sign is it's going to be where the sign is 2. Angle that gives me a sine of 2. If we go into our calculator, second sine of 2. And it's not a number. You may get an error if you're using one of the the calculator that's not on your iPad. Now, why does this happen? Okay, why do we not get an answer? Well, think about it. Think about your original sine function, 1 and -1. Okay, you're never going to get an angle that gives you a sine of 2. And this is with the cosine as well. Okay, so if you have a cosine function value that you're solving for that's greater than 1 or less than -1, you're going to not get an answer. Okay, and that's okay. So going back and putting this all together, our solutions here, our solution set would just be 135 and 315. In example 6, I have 2 cosine theta equals sine of 2 theta. Now this is going to be a little bit of a problem for me. Because first of all, if you notice, I have a theta here and a 2 theta there. But if you remember correctly from our last unit, we can rewrite the sine of 2 theta as 2 sine theta cosine theta. And now if we subtract that over, and in order to solve this, hope you can see that you have a cosine. So we can use GCF. So I'm going to factor out 2 cosine theta. And inside parentheses, I will have 1 minus sine theta. Now I have each of my factors as a single trig function, and I can set each of these factors equal to 0. So my solution is going to be where the cosine of theta equals 0. And then I have negative, or when the sine theta, if I just bring that sine theta, is equal to 1. Now, if you notice, once again, here's where our old units have to come into play. We have to remember that when we're solving for, if we're looking for the angle whose cosine is 0, this is going to be a quadrant angle. Zeros and ones are quadrant angles. So when we're solving for these angles, think of your sine and cosine curve. Where is the cosine 0? At 90 degrees and 270 degrees. The angle whose sine is 1 is just at 90 degrees. So our solution set here, I have a repeated solution, which does not matter, 90 and 270. Okay. So be aware of those function values that are zeros and ones, okay, because you want to treat them just a tiny bit differently. Now to end today, let's jump to like a more difficult type of equation. When I look at this, I see cosine squared x plus 4 sine x plus 4 equals 0. In order to solve this, I'm dealing with a quadratic. So I need to get everything in terms of one trig function value. How can I do that? I use my Pythagorean identity. Sine squared plus cosine squared equals 1. So I can rewrite cosine squared as 1 minus sine squared x. Now I'm going to just work through and combine like terms. So I have negative sine squared x plus 4 sine x, and 1 plus 4, right? I have 1 plus 4 plus 5 equals 0. I want to divide through. I don't want that negative out front, so I'm just going to change the sign. That's just dividing through by negative 1. Now I'm at a good spot because I have everything in terms of one single trig function, and I can factor this. And this is an easy one because it's not even a tricky trinomial. So sine x, 2 numbers that multiply to negative 5 and combine to give me negative 4 minus 5 plus 1 sine x minus 5 equals 0. Sine x plus 1 equals 0. Sine x equals 5. Well, remember, this is, right, the angle whose sine is 5. What do we know about that number if it's bigger than 1? No solution. If you don't trust yourself, sure, go ahead, plug it in the calculator, but it's not going to be a solution. Sine x equals negative 1. Again, since we have a function value that's, if we're solving for a function value that's 0 or 1, we're going to think of our sine curve. right? The angle whose sine is -1 is going to be 270 degrees. So our solution, our only solution, is going to be 270 degrees. Okay. I thank you very much. You guys, we did have a lot that we went over today. I am expecting that you remember some stuff from last year, but hopefully it'll come together for you. Please do your homework and see you soon.